All right, there we go. Okay, so sophomores. Hey, you guys are gonna have to be really quiet, seriously, or you'll have to join the review. That's what it takes. But if you want to be quiet, you can work on your own. Okay, so juniors, let's go through this. I just picked out some questions, and I'm starting on. If you want to go through it in your packet, this is right. So it's on part D. It's on.
How did you staple it?
It's kind of. It wouldn't staple it exactly the way I wanted it to. So yours is going to be there. You go.
Where is
That,
it?
good?
That's not it though. That's not
Well,
it.
it's earlier in part B. Go back this way. I think maybe. Right on this page.
L. Okay.
Oh,
It's
it's
D.
number 3 on my.
I know.
Yeah.
Okay, on part D.
G.
Parts A, B, and
It's
C
right here.
are not priority clusters. So we're just going to start with the priority stuff, work our way through. Now the goal is not to do everything. I just want to. There's a few things I want to point out, some tricks you can do with Desmos and things like that. Yes, ma'am.
Is this part of the SAT or like the
It's
big
for
state?
it's for SBAC, but at the same time it would be good practice for SAT too, because the questions are really similar. Okay, so stuff like this. Now, whenever they're asking you to choose an expression that's equivalent algebraically, what could you do?
Like, boil it out.
You could just simplify everything, right? You could just expand this whole thing out and then expand these out and see which one is it. Now, in the process of doing that, you could probably make a pretty good estimate here. I mean, some of these you could disqualify right away if you just sort of look logically at what these expressions all look like. So this guy, if I expand it out, wouldn't you agree I'm going to end up with a quadratic here minus a quadratic there, right? Well, I'm not going to go through the math because it'll take too long. But you could do that, right? Be no big deal.
Wait, will you go through it though? Because we need to know how to.
Well, you guys know how to do this.
No, but isn't this review?
It is, but what I want to do mostly is, there's no way in 2 days we're going to get a review in of like going through all the processes. I want to just kind of point out what your strategies are and how you can use Desmos to, because you get Desmos
We're
on
allowed
this.
to use that.
Desmos is going to be the calculator for SBAC this year.
Cool.
Yeah.
And like
So-
the graphing part too.
So it'd be, yeah.
Oh, I'm good now.
Okay, now,
I'm fine.
I don't think you get it on every question, but you get it on a lot of them. So it really is helpful. There's some great tricks. So, Lexi, in answer to your question, all you would do here is we would just multiply out x plus 5 squared, multiply out that product, and subtract them and collect like terms. And you're going to end up with some number of x squareds plus some number of x's plus some constant, right? Okay, does that make sense? And you do that for all four, but that's kind of time consuming. So there is another way you can do this. If you pull up Desmos, okay, if you pull up Desmos, actually, I'm going to go to the next question and do it on the next question.
So it's the answer C.
The answer is C, right. Oh, and the other thing I should tell you too, on Moodle, if you go to Moodle, I'll just pull it up real quick. I've added a section in Moodle called SBAC Prep up here at the top. And if you pull this up, what it is, it's got the review packet, which is the yellow thing you've got. It's got the answers to it. So if you pull this one up, see, it's just got, it goes through each of them and gives you the answers, okay?
Does this talk about matrix?
No, no matrices. And then also I included some performance tasks. We'll go through one of those on Monday. But if you want to take a look at those too, that's part of the test is you have to do a performance task. And it talks in here about how it's scored. So you can kind of just, I would just look through it and just say, it kind of gives you some hints about what you should do when you do the performance task. You guys aren't going to have any trouble with this, but I just,
On Tuesday?
Tuesday and Wednesday,
A
yeah.
morning test.
Yes. Mm-hmm.
Since we're gonna be gone Wednesday, do you
We're
think
gonna
we're
do
just,
more.
Oh, it'll be, yeah,
later.
don't worry
so
about
we're
it.
just gonna do it next week after, or we're just gonna stay
No,
there all day?
the week after we have English.
So we're just gonna do all day, or?
No, they're just gonna pull us at a time.
They'll work
At
you
an
in.
unknown time, they're gonna grab us. away
Yeah,
from the class.
they'll just get you out of classes.
Oh, yeah.
Nothing to worry about.
As long as it's not one, just do it.
Okay, what about this one? So this is one where I do want to just review a couple things real quick. So what about something like this, where we want to determine, now this is a kind of question where they're wanting you to essentially answer 4 questions in one. The first one was just a traditional multiple choice. Hey, you guys are, the sophomores, you guys have to be a little quieter. This is just, I know that's not too bad, but it's a little too loud for us up here, so you gotta keep it down a little bit. So they want to know which of these 4 is equivalent to that, right? So mathematically, this is stuff that's right in your wheelhouse. We've done a ton of this, right? This is factoring a polynomial, right? If it's got 2 terms, we would just use our factoring patterns. Okay, if you're looking for that handout, this is all stuff from Module 6, so I think that's 6.4. Yeah, that's in 6.4, factoring patterns.
They're not gonna have that like on the test.
No, they
the way
won't.
you have
They
those.
won't. They won't have. So you need to know those,
Yeah.
right? But those, you guys know those. That's no big deal. So you know those. So we could take this and factor it as a difference of cubes, and if we did, we would get that, right? And once again, this is all just 6.4 stuff. And you can go back if you want to review that a little bit. This is 6.4. If we factored out the 27 first, we get that, right? But these kinds of questions, there's a much easier way to do this, right? And with or without Desmos, you can do this. With Desmos, I could just graph these and see if they overlap, right? The other thing I could do with Desmos that's pretty cool, it's really handy actually. Let's see here. So we could do, like, let's call this first one, when I put that in, I'm going to call it f of x. I'll tell you why here in a second. So I'm going to define this as f of x equals, and then I'm going to put in this original expression, 27x cubed minus 729. Okay, and it graphs it for me, right? And if I want to, I could like zoom way out so I could kind of see what that looks like a little bit. Oops. I think I zoomed out way too far. Let's zoom in. Yeah, it does. It's going to be a cubic, so it's going to go up and down a little bit. Well, I'm not going to bother with the graph. You'll see why in a second. We could mess with the graph and compare the graphs. I'm going to call these other ones, and this is not a bad habit to get in. Let's call it a of x, b of x, c of x, and d of x. Okay, so a of x, and normally, like if I were just to put y equals, it would still graph it for me. Or if I even put in the expression, it would graph it for me. But I'm writing it as a function for a reason.
Are we gonna get our graphing calculators as well, or?
No, no.
Our
This
graphing-
is your graphing calculator. Yeah. So this would be the quantity 3x minus 9 times 9x squared plus 27x plus 81. Okay. And so they look like they line up. Once again, we could zoom out and see if these graphs truly match up. But here's where I'm going to go with this, and I'll just give you a quick little insight. So a great trick that I use very liberally on lots of my standardized tests in grad school and SATs and things is you can always, if you want to check to see if expressions are equivalent, you can plug in a number. Just pick a random number and plug it into the original expression. Pick the same number and plug it into these, and the one that gives you back the same number is it. And if you get more than one well, in this case, you might get more than one because there's 2 correct answers, right? But if you just pick a random number,
Like 1.
well, 1, sure. I mean, 1 would work, but sometimes like 1 might be a special number where it might be designed so 1's going to give you some false alarms, right? But then if you pick 2 of them, what are the odds they're both going to work, right? So like, let's say we went through this and we picked, let's just say we picked 2, for example. We plugged 2 into this expression and we got the same thing with 3 of them. I could go through and check those 3 again with a different number to disqualify any false alarms. See what I'm saying? It's great. I mean, it really works. Now with Desmos, if you have Desmos available, look how easy this is. Like if I define f of x as being the top function, if I want to plug a number in for f of x, what would I do? F of what? Like 11 or something, right? If I just pick a random number, there's the value. See? That's the value of the top expression when x is 11. So then I could just go down and say, okay, well, what about a of 11? Same thing, right? So they're the same function. That's an awesome trick. I mean, you get so much mileage out of that trick, seriously. Okay. Everybody understand that? And once again, you don't even have to, like I could do this easily if I pick 2 or something. I mean, I can do that math. It's not, you can just write it on paper. You know, even if you don't have a calculator, you can do that arithmetic pretty easily on your own, right? Even if you didn't have the calculator, that trick is still available. Okay. Okay, stuff like this. So all they're doing here, this is where they're asking you to go through a process. You'll see some like this. They want you to go through a process of simplifying this expression, right? And so it might look a little mysterious. When you first look at that, it might look like, wow, what are all these boxes in these weird places? But if you start the process of simplifying, it just makes sense. All they're doing is getting a common denominator, right? So for example, I'll go through this one really quick. So if we're trying to add those two things up, look what we've got. We've got 6 over x plus 5 over the quantity x plus 4, right? So if we want to add up fractions, what do we have to do? Common denominator, right? Common denominator. And so our common denominator is just going to be the product of those two factors, isn't it? Our common denominator is just going to be x times x plus 4, right? So to get that, what are we going to have to do? We're going to have to multiply the first fraction by the quantity x plus 4 over the quantity x plus 4, and the second fraction by x over x, right? And so now you can see, you kind of see what's going on here, right? So on the bottom, we've got our common denominator. On the top, we've got 6 times the quantity x plus 4 plus 5 times x. Okay, make sense? Yes?
That's a question, like, so like 6 over x plus 5 over x is 4. So if we would like to cross.
Well,
Six
you
and 4, so that gives the same answer.
if
I'm
you
not saying like cross multiply.
well
but
you
it's the same
can't.
answer.
Okay, so no, you can't really cross multiply here unless you were to subtract this one to the other side. But that would be solving for x, right? That's different than just trying to simplify this. We're just trying to add this up. Okay, so this would be one where, I mean, I know this has variables in it, but the other thing you can do sometimes is if you're just unsure about a process, sometimes you ask yourself, what would I do without variables, right? And then just do the same thing with variables. Like for example, what if we were going to add 2/3 plus 1/4? You know, what would you do? With numbers, sometimes you can get a least common denominator that's smaller than the product, but you always could. It's still going to give you a right answer. You may have to reduce your answer, but you still could always just multiply by the other denominator, top and bottom, right? And it would work, right? Okay, same thing up here. Okay? What else? Okay, it's more of the same. I'll just skip this one, right? This is just, if you were to go through and expand this whole thing out, they just want to know in your answer, fill in the blanks. What's the coefficient of x squared and what's the coefficient of 24? And you're going to drag this stuff in from a box on the test. Okay, no big deal. What value, when placed in the box, makes an equation that is true for all values? Okay, so same thing. You could just go through mathematically. You would just go through and expand out this expression and see what the coefficient of t was, right? But what else could you do? Well, how could you trick this one or check it?
We'll go like into T's over,
Say it again.
like put the numbers up there maybe into T.
You could, right? And then pick a value of t, right? Pick like t equals 2 or something, and see which one, right? Does that make sense? And if you get one that works, like let's say we try t equals 2, and we're going to see, okay, so then, and we could even say, okay, if t is 2, then what would have to go there, right? We could even, see what I'm saying? Like if t was 2, what would we get? We'd get a value like, here we get -1 squared, which would give us, let's just go through and do one like this. So if t equals 2, that whole thing's going to give us 1 plus 41, right? Over here, we're going to get 1 plus something times 2
When we get
plus 50. But
t squared, if t equals 2, how's it 1 on the right side?
say it again.
How'd you get 1 for?
Oh, you're right, sorry, it's
2
4.
minus 3.
There you go. And that should be a, yeah, there we go, okay. Does that make sense? Yeah, sorry. So what are we gonna get then? So this is 42 equals, so 4 plus 50 is 54, right? 54 plus, we'll just call that 2x, where x is our, this is x right there, right? Make sense? So if I subtract 54, what I get, negative 12 equals 2x, so what's x? Negative 6. See what I'm saying? So once again, you can just trick it that way, right? Or check it at least, right? Okay. It seems kind of weird to be talking about how to legally cheat on these things, but it really is I mean, you're gonna take so many of these tests, it just pays to kind of learn to think about it this way a little bit.
Do we have to take it again next year?
No, but you already,
Unless you don't pass it.
no, you only take it once regardless, I believe. Yeah, you guys.
Don't you have to pass it to graduate?
No, you have to pass
If you
essential
have work
skills.
samples.
You might be able to take it next year, but you guys, don't worry, you'll be fine.
Well, what
Already
happens if
have
we
it.
don't pass it?
You will. I promise you will.
For people that don't.
Nothing. I mean, you could, I think maybe you could take it next year, but you don't have to.
So why does it matter if you take it if it?
Well, it's a good test to pass.
And how
It's-
come they
it's on-
tell us that it is required for graduation?
It's not.
Because that's what we've always been told,
Yeah,
that
we've
you
been
have to
told
pass
that.
smarter balance
Oh.
to graduate.
No. There's the test, the essential skills test, you can take that and that counts. That one, actually, that's the one I wrote. You can do that one and it's, that-
Have we already done that?
yeah, because you already done it, so you've already met your graduation requirements.
Why did they
tell us
lie?
that?
Then
Yeah,
why did they
they're
lie
like
to us?
making us so much more stressed.
I was
Yeah.
told, I was told during graduation that.
Literally, we've been told since we were freshmen that to graduate we have to pass it.
smarter
And
balance.
it's a huge deal, if you don't
No,
pass it,
I'm
you have to do a
taking
whole
it.
bunch of work samples and it's super hard and difficult, so you better just pass it.
And
Okay,
we've been freaking
Yeah,
out.
but the work samples, the test you took replaces the work samples.
Then why would they tell us that?
They must, I don't know, they must not have known.
Because they put a bunch of pressure on us about this, and we've only heard it just this week. They're like, oh, and by the way, you're taking this test that you need to graduate next week, and you're
Oh,
just gonna
no.
run out. Why
Yeah,
prepare for it
that's
a week
what
before?
Like,
No, you're fine.
Oh my god.
It's, you guys, you've all met your graduation requirements, that's not a problem. But it is a good test to pass, because I think it is a transcriptive test, and so it's something that you could send off to colleges, I mean, you know what I mean, it's something that could impact positively scholarships and things like that. So
But it can't impact us negatively?
I don't think so, I don't think so, yeah.
Okay.
But you wanna pass it.
Yeah.
Okay, so, anyway, back to business here, same stuff, right, same exact trick, okay? Same exact trick, you could just, you got this expression equal to this expression, pick a value of x, let x equal something, and then just solve for, solve for that
You
unknown.
can choose any number for x equal.
Yeah.
Okay.
I mean, if you pick a number like 0 sometimes or something, it
But
may.
2 is usually pretty safe.
Sure. Yeah. Okay, so, all right, so moving on. Okay, what about this? So this is piece of cake, right? This is just saying, you gotta read through this stuff. There's a lot of reading on this test. So 3 equivalent equations for f of x are shown. Circle the form, right? So that's what you wanna do. Circle the form that reveals the zeros of f of x without changing the form of the equation. Well, that's it, right? If we want to find the zeros, what's it mean to find the zeros? The zeros of a function are the values that make the function 0. So if I set all of these equal to 0, what they're really saying is that which form allows me to inspect the equation and get the zeros?
So basically the one without any squares.
The one that's factored,
Mhm.
right? Because then we can use the zero product problem, right? Does that make sense?
Mhm.
That's all they're saying. And then, so what are the answers? Well, 5 and 9, right? Okay, and you've done a ton of that, no big deal. But make sure you gotta read through the questions and just maybe more than once, and slow down when you read them and just let yourself have a chance to digest them. And then, interpret the question. Yeah.
I thought when like factors, actually I have a negative 3 in that. I thought then it was automatically a 0 is one of the answers, if we have a factor.
If there's an x out front.
So if it was negative 3x, that'd be a 0.
Right, exactly. But -3, no, I could just divide both sides by -3 and get rid of that.
Okay.
Right. Only factors with a variable in them are going to give you solutions, right? Okay, so Okay, this is, I'm not even gonna, for you guys, I'm not even gonna mess with this. These are just properties of exponents. I mean, you've done a ton of that, no big deal. We just did that recently. This is kind of an interesting one. They want you to write an expression equivalent to x to the 18th in this form. Well, there's a bunch of different answers, right? Because you know if you take a power to a power, you multiply the exponents. So n and m would just have to multiply to what? 18. So it could be 2 and 9, could be 3 and 6, could be anything, right? 18 and 1, yeah. Could be any of those. And then this is, all you're doing here is just properties of exponents. No big deal. You guys have done a ton of this stuff. I'm gonna skip that. Okay, this is one I wanna go through a little bit. Okay, so there's something I wanna sort of just augment a little bit, something we did. We in our book, we did standard form equations and parabolas written in the form over on the left, right? Remember that stuff? Where we wrote equations of circles and parabolas using that form. There's another form that we also used indirectly that I just want to remind you about. So if we want to put it into this form right here, what are we really doing? All we're doing is just completing the square, right? So if we start with this equation up here, if we've got, I'm going to make that a y. If we've got y equals x squared minus 10x plus 36, all we've got to do on this is just take these first two terms and complete the square, right? So we could say something like y equals x squared minus 10x, and let's just keep the plus 36 over here. What's the number I would have to add to those first two to complete the square? Right, because I'm going to end up getting the perfect square, some perfect square there. Remember that stuff? If b is negative 10, what do? What's the number you add to x squared minus 10x? Negative 5 squared, right? So we'd add, to get x minus 5 squared, we'd have to add 25, right? But to both sides. So let's add it to both sides of the equation, and then there's the part that becomes the perfect square. See what I'm saying? So then all we'd have to do is subtract the 25 back from the 36, and you'd get y equals this plus, what, 11?
Wait, how'd you get the 11?
Because I just subtracted that 25 from both sides. Right. This 25 got used with the first two terms to make a perfect square. This one we had to just assimilate in this number then. Okay? No big deal, right? And so then if you do that, if you write it in that form, now we know what A, H, and K are, right? A is 1, H is negative 5, K is 11. And what that also allows us to do, there's some other questions that could come up where they want you to to graph a parabola based on a parent function, right? And so we could take the parent function y equals x squared, and we could easily transform that using that, right? I mean, this tells us, we're gonna take that parent parabola, vertically stretch it, or shrink it, maybe reflect it, right? Slide the vertex left or right and up and down. Okay. All right, what happens if you get one like this? Okay, no big deal. So let's try one like this now, where same deal. Let's call this y. So we have y equals 2x squared minus 12x plus 26. Okay. To complete the square, there's a bunch of ways you can do this to organize the algebra, but I think this is pretty easy. I like the idea of just pushing everything away from the two terms that you want to complete the square with, and then you can get them back later, like we did on the last one, right? We added 25 to both sides, right? And then we just pulled that 25 back over. Right? Okay, same thing here. So we want to get rid of that 2 though, right? We got to be able to write this in the form x squared, plus or minus some number on this side, right? So we're going to divide both sides through by 2, okay? So then we get y over 2 equals x squared minus 6x plus 13. Okay, now what? What's the number that goes with those to complete the square? Plus 9, good, because we're going to get,
Okay, how?
because it half of negative 6 squared, right?
Okay.
So it's going to equal x minus 3 squared, but to do that, we've got to add 9 to both sides, right? Okay, and then this stuff right here becomes that. Right? And then you just end up with x minus 3 squared plus 13 equals y over 2 plus 9. So then we're just going to isolate the y, right? Just get that y by itself again. So we subtract 9 from both sides, right? Which gives us y over 2 equals x minus 3 squared plus 4, and then just multiply by 2, right? Multiply a 2 through both sides. And we get y equals 2 times the quantity x minus 3 squared plus 8. Okay? Now, if you have Desmos available, you could also just do this, right? You could also just graph that function, right? And on Desmos, it'll give you the vertex. It'll give you the coordinates of the vertex. Now, what do those represent? H and K, yeah. And you know what A is, because A is the number in front of x squared anyway, right? You see what I'm saying? So I'll just demonstrate.
Do we need to have the triangular formulas and the circle formula memorized?
You know, I don't think circles are even going to show up on this. I really don't.
But for all we need to know the equations.
Yeah.
Do they provide any equations for us, like they do on some of the tests? I know some tests do and some tests don't.
I don't know the answer to that.
That's-
I'll find out.
Okay.
I'll find out.
That's a good thing to know.
Yeah.
I don't remember.
Okay, so on this one, what did we have again? We had f of x equals,
2x squared minus 12x plus 26.
okay, there we go, 2x squared minus 12x. Yes, you bet, plus 26. Okay, so there's the graph right there, right? So all we got to do, what do you know? There's my 3 and my 8, right? H is 3, K is 8. And if you really wanted to, you could even go over here and say, okay, well, let's see, the vertex is at x equals 3, right? So what if I were to, if I want to find out if I go over 1, how far up do I go? Because I should go up 1, right? That would give me A. I already know A is 2, but I'll demonstrate it for you here. If I do x equals 4, look where the intersection is. It's at 410. And so we went up, instead of going up 1, we went up 2. So A is 2, right? Okay, so with Desmos, you can do, you can do a lot. Okay, so what about this guy here? So they just want to know which equations reveal the minimum or maximum values of f of x. Well, what would they really be asking there? So reveal the minimum or maximum values. That means it's showing you, these are all parabolas, aren't they? So which ones can you see what the coordinates of the vertex are?
The ones in standard form.
Yeah, the ones that are in, that are written in the form where, right? Standard form where we've just transformed a parent function. So it would just be b and d, right? They don't even ask for what they are. They just want you to recognize that those are the ones where you could tell that the vertex is at 3, 2, and -4, -7, right? And because you know the sign of A, you even know if they're opening up or down. So if it's a minimum or maximum, right? Okay. No, we just combine like terms. So easy. That's nothing, right? You're just combining, you're just distributing negatives and adding like terms. No big deal for you guys. In this case, you could do the math pretty easily, right? Just either expand it out and see which one it is, or if you want to, you could even pick values, right? Pick values for x and a and see which one works. That trick is awesome. Okay, no big deal. Multiplying polynomials for you guys, that's a non-issue. For you guys, this stuff is a non-issue too. You guys know this stuff well. Every time this comes up, you've had no problem with it. So where you're just trying to take something like if y represents distance, r represents speed, t represents time, it's just distance equals rate times time, right? Is all you're doing. And so they want you to do something like write an equation where you're just plugging in values. So they're giving you that. And you're just plugging in values for distance of 75 and time for 5 hours. That's it. I mean, it's, you're just evaluating an expression. Okay, this is one, I mean, you could all do this, but I just want to just point out that this is one kind of thinking you might have to do on the test where you're given an expression, or you're given an explanation like this, and you're supposed to write an equation, or in this case, an inequality, right? So a clerk earns $150 per day plus a commission equal to 8% of her sales. So what would you do with 8%? When you want to treat that in a math equation, what do you turn that into? 0.08. 0.08, you make it a decimal, right? So then, doesn't it make sense that the amount that the clerk is earning is just there's 150, which is constant, right? That's the start value, plus 0.08 times S, if S is sales, right? And then when they say the clerk earns less, clerk earns less than 210, just becomes an inequality instead of, right? And they might use language like, what if it said the clerk earns at least 210? Then it would be greater than or equal to, right? So you have to kind of interpret the language sometimes.
For inequalities, you flip the sign when you divide or multiply across.
By a negative, yeah, by a negative.
Only by a negative.
Only by a negative. Yeah. Otherwise, it's just the same as an equation. I mean, these, it's just a story problem. You guys you can figure this stuff out. You have to think about those a little bit. I mean, a lot of this is mostly for the regular Algebra 2 classes. Only some of this applies to you guys. I mean, this would be where you're just creating two lines, right? So the equation, or the answers are the red lines that are drawn here, right? So the school is having yearbooks made. One of them charges $300 to set up the printing, and then $25 per yearbook, right? So the number of yearbooks. So it's just gonna go up, the slope is just 25, right? And you're just gonna create that line. Pick 2 points, convenient points. So the convenient points would probably be something like you'd go over from 300. If you went up, what do we want to go up, like 250? Or like 300. So if we went up 300, we'd be right on 600. So how many would that be? 25 goes into 300 12 times, right? So if we went over 12, we should go up to 600, right? And then other one, we're starting at 400 and the slope is 15. So just pick another convenient spot. Connect the lines. That's all we want. No big deal. And then along those lines, no pun intended, it's a little different actually. So find the value of x that makes the equation true. What would you do here? Yeah, this is an equation. If you're solving an equation that's a ratio, what do you always do? Cross multiply. Yeah, just cross multiply.
Could you put in the Desmos to figure it out?
Say it again.
Could you put in the Desmos and figure it out?
If you have Desmos, you could, sure. You could, yeah, you could. This is when you're solving though, I mean, what you do is you could, in Desmos, how would you do it? You would just set up, you could graph like one equation that you'd graph, one graph would be this and one graph would be the right side, you see where they cross. Right? You could do that also. I think personally it's a lot easier and quicker just to cross multiply and solve this one though. Okay. And then, of course, whenever you're solving an equation, you always check it, right, by plugging the answer back in to see if it gives you the same answer, right, on both sides. Okay, we just did all this stuff, right? This is, we just did this, so this should be fresh in your mind. What do you do when you have a square root? Isolated? Square both sides. And then make sure you check the solutions to see if one's extraneous, right? But no big deal. That would be considered a really hard one on SBAC, and you have easy for you guys. So.
Are you reviewing also with your normal classes?
Yeah. It won't go quite as quick with the normal classes, but yeah, we are. So choose whether each equation has no real solution, one real solution, or two real solutions. You can see stuff like this too. Like this one right here, this would be one where, we could just literally just solve this thing, right? And see that we're only gonna get one solution back. Okay, this guy here, we could solve that also, right? And if we have Desmos available, we could just graph that and see how many times they intersect, to check it at least, right? Graph that, graph the line y equals 3, see how many times they intersect. How does that have 2? Oh, yeah, it does, never mind. And then, what about this one? How can you see right away that it has no real solutions?
It's equal 0,
Yeah, 0 plus 7 doesn't equal 0. That's the lowest possible.
and it's like a
Okay.
negative, if you like
If
move
you
the
had
7, it's
-7.
negative.
Exactly. If I isolate the radical, I get the square root of x equals -7.
You can't square the negative, it ruins it.
Yeah, right, a square root, the output of a square root function can only be non-negative, 0 or positive, right? For real numbers, right? So it has no real solutions for sure, okay? And you could, I mean, if you actually solve it, you can solve it, but you're just gonna find out when you plug the solution back in, it doesn't work, it's extraneous. But you don't need to, right? You can see that pretty quickly. Same kind of thing here. And then, of course, if you get infinitely many, what does that mean? When you solve it, what are you gonna get? Right, but you're gonna get something like 1 equals 1, or you're just gonna get some true statement, right? It's always true.
Are we gonna get review also for English?
I don't know. I don't know.
Are you just doing this because, or were you told to?
No, I'm just doing it because, yeah. I mean, I don't want, you guys shouldn't feel pressure on this, but you really shouldn't, but it's,
So why are we doing exactness?
well, because it can be good. It can be, this
Is it
is
like for
something,
colleges sort of?
yeah, for colleges, right,
Kinda,
It
it's kinda
has
like,
potential for scholarships.
right.
is it kind of also like taking the SAT sort of, like?
It
It's
is.
like a free SAT.
It is, exactly. It's like a free, it's equivalent to an SAT or an ACT math
What's
test.
it out of?
I don't, they've changed it. I don't even know. It's,
So-
the format's changed
Is
each
it
year.
gonna tell us at the end of it what our score is?
Or do we have to wait like 5 weeks?
I don't know that either. I'll try to find out. I'll try to find out.
Find out what a good score is.
Yeah.
That'd be good.
Okay, so if we solve the equation for M, what are we doing here? This is piece of cake for you guys, right? If I want to isolate M, what do I do first?
Multiply both sides by 5.
Multiply by 5 halves, right? Get rid of that, and then
Square both sides.
square both sides, right? No big deal, okay? This is no big deal. I'm gonna skip all this stuff. That's nothing. That's nothing. You're just solving an equation. Okay, solve the inequality. Here's, real quick, I mean, this is a piece of cake, but I would subtract the 12. When I divide by the -3, that's when I have to flip that inequality sign, right? No big deal. Okay, this is, once again, to me, this is kind of the more important stuff, being a calculus teacher, and so we spend a lot of time on solving equations like this. So this is one where there's only, if we're just trying to find real solutions, because there's a single x I can point to, I can just isolate it, right? I would add 72, divide by 8, square root both sides, and if I square root both sides, I have to add a plus or minus, right? No big deal. Something like this would be a magic number one, wouldn't it? Right, if I subtract the 3x back here, I'm gonna end up getting a simple quadratic where I can just pick magic numbers. I could always rely on the quadratic formula, right? Which of course you need to know. And then here's an example where you'd have to just use the quadratic formula. And notice here, okay, I want you to notice one thing. It says, what are the solutions? Does it say real solutions? No. So it implies all solutions, right? Complex solutions. And so we would, when we use the quadratic formula, we would end up getting some i's in there, okay? Okay, here's another one. Let's talk about these two. So you can be real logical about this. Now, if we've got an equation like this, where k is a real number, find a value. I just want you to pick a value of k so that it has no real solutions.
Just make k negative when you.
So k would start positive, right? If k is a positive number, then I'd get something squared equals a negative, which would cause me to have i's when I square root it, right? Good thinking. Okay, here's another one. What about this one? Same question, but what about b? Okay, this takes us back to the discriminant, right? Remember, the discriminant is just the part inside the radical, because that's the part that determines if you have i's, doesn't it, right? If that part is negative, you're gonna have i's. And so if we were to go through this then and say, okay, what's our discriminant? Well, A is 1, B is B, and C is 4, right? So the discriminant D would just equal B squared minus 4 times 1 times 4, right? And so that would need to be, we're trying to find values that make no real solutions. So it would have to be less than 0, right? So then we'd get B squared is less than 16. Okay, this is the part that's a little bit tricky on this though. If B squared is less than 16, what if I square root both sides to solve for B, right? If I square root both sides, the square root of B squared is what? No, it's actually the absolute value of B, right? It's the absolute value of B. Now, and think why. This is, we talked about this, but it was a long time ago, right? And it's actually, this is more of something we talk in more detail about in calculus, honestly, but it's good to know. Test a number in here. If I put in -3, what's -3 squared? And the square root of 9 is? So it's absolute value, isn't it? It spits out a 3, right? So square root of something squared just becomes the absolute value, right? And if the absolute value of B is less than 4, then that means that either B is less, remember how we do that with an absolute value equation? If the absolute value of something is less than 4, then that means that B is going to be trapped between +4 and -4, right? But you could almost just power through that by thinking about it up here. If B squared is less than 16, right, then you know that the magnitude has to be between 0 and 4, but it could be negative, right? That's a harder one. And by the way, you don't have to get everything right on SBAC. I mean, if you can miss quite a few and still do really well on it too.
So do we have to take a placement test for next year, or is it just a sophomores?
We've always had a placement test. I think it's a horrible placement test. I'm really kind of pushing for not having one, but at this point we are going to do one.
Okay, is
You
it
guys will be fine though.
is it to like get into like the math class you signed up for, or like?
It's to get into pre-calculus.
Okay.
Yeah, but you guys will be fine. I mean, we're going to do a final at the end of the year that's designed to kind of get you ready for the placement test.
Okay.
So you'll be fine.
Wouldn't it be easier to just square root it and think of it in terms of ±4 and put the B in between?
Well, I mean, kind of, but this is just one of those things that we just know to do, right? If we have,
Okay, so
if we
it would
solve,
work in
if we
this
solve
set-
an absolute value equation like that, we know that if we have the absolute value of hand is less than a number, then hand is greater than
Gotta be
negative the
negative.
number and less than positive the number.
Right. So, like, it works in this situation, but it wouldn't work in every other situation. It wouldn't work in every.
Yeah, I mean, there's some problems with what you're suggesting. I see where you're coming from, but it's just not mathematically, technically 100% correct.
All right.
Because that's absolutely, really, that's how you do it. All right. Ruby, question?
Can I be requested?
Yes, you can.
You request me too.
Yeah.
What are we doing today?